Okay, the next brief topic we're going to touch on here are electron orbital diagrams. So what these do is these now show the electrons in their orbitals. Now, it helps if you first thing typically that helps is to write out your electron configuration. So let's do this. Let's think. A good one to do this for might be, let's do it for sulfur. Okay. Sulfur. So sulfur's electron configuration is going to be 1s2, 2s2, 2p6, continuing on 3s2, and then 3p4. All right, now, how do we draw this? Well, what we do is we now have to draw our actual electron orbital diagram. 1s is the lowest energy, so we put a little box. One box represents an orbital. So now to construct your diagram. 1s, now we get to 2s, is just going to be one little box for one orbital. Then we get to 2p. Here we need actually 3 boxes because we need 3 orbitals within a p subshell. Then we get 3s is again just one orbital. And finally, we hit the 3p, which is our uppermost here. So 3p like so. Now, a note, you want to represent electrons as arrows with only one little tine or barb or whatever that little part is called that sticks out on the side. So, because that represents that half a spin. So that is positive a half with a little barb coming up, and a down spin would look like this. This is minus a half. And remember that there are 2 electrons per orbital as we go through this. So within the same energy level, same subshell energy level, we fill 1 electron and then 2 electrons. We go 1 electron and then 2 electrons. Now filling the 2p, we go 1 electron, 2 electrons, 3 electrons, because electrons space out within there because they are negatively charged and they want to be as far apart as possible. Then we get 4, 5, and 6. In the 3s, we now have just 1 and 2. And in the 3p, you can see we have 4 electrons. So we go 1 electron, 2 electrons, 3 electrons, and finally the 4th electron falls into somewhere like so. Okay, so you always, when you hit a new subshell energy level, space out the electrons, spin up first, then come back and backfill with spin down. I'll do a couple more examples and we will leave this topic at that. Next example I will do is, let's look at, how about cobalt? So cobalt is going to be a more complex one. Cobalt's electron configuration is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s, it's going to be 4s2, 3d, and cobalt is going to be 3d, 1, 2, 3, 4, 5, 6, 7. Looking at my periodic table, I count over 7 spots within the d subshell. So 3d7. Now, let's build our orbital diagram. 1s, 1 box because it's just an s subshell. 2s box, 2p. We've got our 3 boxes for the 3 orbitals within that subshell. Then we go to 3s, 3p. Because it's p again now, it's going to be 3 orbitals or 3 boxes. The 4s has only 1. And now we get to 3d. Because it's d, d has 5 orbitals, which is going to be therefore 1, 2, 3, 4, 5. Now we start filling our electrons. 1, 2. 2s is 2. 2p, 1, 2, 3, 4, 5, 6. 3s, 1, 2. 3p, 1, 2, 3, 4, 5, 6. 4s has 2, 1, 2. Now finally 3d is 7. So 1, 2, 3, 4, 5, 6, and 7. And there is your orbital diagram for cobalt.